see what I have here. All right, cool. So line 7, one endpoint is A, and the midpoint is M. Find B. Okay, so we have basically, if we're going to draw a graph here, we have A, midpoint, and B. Now, remember to find the midpoint, right? M is equal to, let's see, this is going to be a, so the midpoint for the X, right, is basically going to be X1 plus X2 divided by 2. And the midpoint for the Y coordinate is going to be a Y1 plus Y2 over 2. Now, you might say, well, what's Y1 and Y2, right? Well, this point A we have is 3, 5. Now, we can call that a X1 and Y1. And then B is going to be, we don't know what that is, right? So let's actually call that a X2 and a Y2. Then M, we actually know. Now that's negative 1.5, but what I'm going to do is I'm actually going to rewrite that as a fraction. So I'm going to rewrite this as a negative 3/2 and a 3/2. Okay? All right, so now that's the X coordinate, that's the Y coordinate. Actually, let me rewrite it like this. So that is going to be my X coordinate and my Y coordinate for the midpoint. So if we know that this is negative 3/2 equals X1 plus, we don't know what X2 is, that's our unknown, divided by 2. Okay, and when we go ahead and solve, you multiply by 2 on both sides. You get a negative 3 equals 3 plus X2, subtract 3, and you get a X2 is equal to a negative 6. Okay, so that's a negative 6. And then let's go over this one, exact same thing. This is going to be a 3/2 is equal to a Y1, which is 5, plus a Y2, which we do not know, divided by a 2. So again, multiply by 2 on both sides. That's a 3 is equal to a 5 plus a Y2, minus 5, minus 5. That's going to be a negative 2 is equal to a Y2. Voila. Next question. So as you guys are kind of going through these, I'll just kind of post up this. Again, if you guys have questions, like feel free to go ahead and submit them there. As well as you can also go to Discord. So the Discord, as you guys have questions, these are all questions that were pre-submitted. And I'll try to see what other additional questions I can go through tonight. But when you have questions, the best thing to do is to submit them. So therefore I can get them up on the screen, because otherwise it just takes too much time from there. So if you have questions, submit them using that link, and I will try to do my best to get them either tonight or definitely hopefully next week. If I don't get to them, you can also go and post them also in Discord. All right, now on this one, I remember this one actually came through last week, and I was like, I'm not sure of the elementary function, so I'm assuming that this one is 1 over x. Now, so if it was 1 over x, then this would be correct. But if you apply these transformations here, the g of x then is now going to look like this. So it's going to be a negative 2 times a 1 over a 2x minus 1, and then plus a 4. So technically the graph is going to look something like this. So negative 2, 2x minus 1 plus 4. Okay, so if it was just 1 over x, so if I just said, let's say f of x equals 1 over x, right? So therefore my vertical asymptote is going to be, I don't know why I do it like that. So my vertical asymptote would be x equals 0, and my horizontal asymptote is y equals 0. Okay, so now we need to understand, well, what's going on here? Like, what are the transformations that are going to be impacting my graph? So if you look at this 2x minus 1, what that's going to do is that's going to shift the graph. That's going to be right 1/2. Right? Because if you basically, what that's going to do is you'd have to factor out the 2. But basically, if you were to go ahead and rewrite this, you can rewrite this as a 2 times x minus 1/2. Okay, so therefore that's your B and that's your C. All right, so if you're looking at the transformation kind of form, so therefore that's going to be shifting it right 1/2, and then this is going to be an up 4, right? So shift. So if my vertical asymptote was at 0, but I shifted it 1/2 to the right, then therefore x is going to equal 1/2. So the only one that's a 1/2 is going to be A. And then my horizontal asymptote is at 0, but then it got shifted up 4, is going to have a horizontal asymptote at 4, vertical asymptote of x. Yeah, there you go. Next one, say find the infinite sum of the geometric series if the sum does not exist, type D and E. Okay, so at this point, we just need to remember the formula. And actually, I remember this one from last week as well. And I was like, I don't remember the formula. I don't want to go ahead and plug it up. So the sum here, in this case, is going to be A over A1 minus R. So A times R to the n minus 1. So in this case, we have our A, which is going to be a 5. So I'm just going to do 5 all over my 1 minus my A, which is a negative 1/9. Okay, so all right, let's go ahead and take a look at this here. So 1 minus a negative 1/9 is really just a plus, so 5 over a 1 plus 1/9. Okay, so 5 over, I can rewrite that as a 9 over 9 plus 1/9. So it's going to be a 5 over a 10/9, right? Now what you can basically do is just multiply by reciprocal. So 9 over 10 times a 9 over 10. So therefore, that's going to be left with a 2. So my final answer is going to be a 9/2. Now this is kind of an interesting question. I didn't really know. So I have a way to solve this. I'm not sure if it's the exact or the correct way, but we know that a question does not have a solution. For instance, like if I had a 2x plus 5 is equal to a 2x plus 1, right? Because once you go ahead and solve for x, like you get the x's on the same side, you get 5 equals 1, which is incorrect, right? So I was like, all right. So my thought process was like, well, if I have 7x minus 4 is equal to a, let's go ahead and distribute this, a 2bx minus 6, basically I want these two things to be the same, right? Because these are not. So that's not going to make a no solution. So that's good. So basically what I want to do is say, well, if 7x is equal to a 2bx, like solve for b basically. So what I did is basically divide by a 2x on both sides. And therefore I got b equals a 7/2. So when that does work, what you're going to get is you're going to get a 7x is equal to 7x. And obviously -4 and -6 on opposite sides, that would create a no solution. So that at least works. That is a solution. I don't know if that's the only solution. I'd have to kind of spend a little more time looking at that. All right, this next question, the student was asking, like, how to convert from radians to degrees. So a couple things you just need to remember is, okay, so remember the difference between, what pi comes from. So remember, when we take a radius of a circle, right, and we wrap it around a circle, right, that is going to be our radian. And when we take 2 of them, and then we can take 3 of them, right? So halfway around a circle is going to be pi. Now, we also created this new degree measure, which is going to be degrees, which we know a straight angle is going to equal to 180 degrees. So the important thing is pi is equal to 180 degrees, right? And you can also write that the other way. You can say 180 degrees is equal to pi. So when I write this example here, when I write 180 over pi, that's equivalent, right? I'm not changing I'm not changing anything, because 180 over pi, like if you so the question is, how do you convert negative 34 pi over 6? How do you rewrite that in terms of degrees? That's not what I did. I don't know what I was doing. Okay. Well, so the first thing I did in this problem was I reduced this problem, because if you look at this, if you go all the way around a circle, and this is actually kind of a can be a confusing problem, because it's a pretty big angle, negative 30 pi over 6. So the first thing what I did is, actually I shouldn't have written it like that. I should have taken out the negative here, and I can rewrite this. So forget the negative. Now what we want to do is rewrite this with how many revolutions. So all the way around a circle, if halfway around a circle is pi, then all the way around the circle would be 2 pi, right? So what I can do is I can rewrite that as a 12 pi over 6, because wouldn't you agree that 12 pi over 6 is equal to a 2 pi? Yes. And again, it's just dealing with we want to keep the same denominator there. Now, if I did this again, 12 pi over 6, that equal to a 24 pi over 6. Now, I can't go to 36, right? So I can say a 10 pi over 6, and that is out of range. So my point that I was trying to make, at least in this video, was we don't really care about these two. Like that's just an extra revolution wrapped around the circle. So technically what this graph looks like, if you were to go and like forget that the negative version, so the negative is going to go, you're going to go around the circle once, around the circle again, and then we're going to go 10 pi over 6. So it's going to be all the way somewhere right there, right? So what I'm saying is why go around the circle twice just to get to this angle, right? We don't need to do that. But so that's why I'm getting rid of them. So this is equal to a negative 10 pi over 6. Now that is what I'm going to do is now I'm going to multiply this by 180 degrees over pi, right? Because again, 180 degrees is equal to pi. So these, like, if you divide something divided by itself, that's like dividing 1 foot divided by 12 inches. It's the same measurement, right? So it's just different units. But what this does now is that goes and simplifies, gets rid of my pi, and then 6 goes into 180. That's going to be 30 times. 30 times negative 10 is going to be a negative 300. And there you go. Hopefully that was better explained. No, pi is not a variable. Pi is the number of radiuses wrapped halfway around a circle. So it's not a variable. All right, this one. So we have some logarithms again. Cool. So the cool thing about this problem, I think, well, the confusing thing about this problem is I'm not sure, this has to be in parentheses around here. I'm not sure why they didn't use parentheses here, because you can't have a log base 20 of nothing, right? Minus k. That doesn't make sense. So it's going to be of negative k. Now the logarithms, you have a log equal to a log, so you can just cancel them out technically, or just set the arguments equal to each other. That's a better mathematical way to set it. And then I have negative 2k minus 3 is equal to a negative k. And now we just got to basically solve. So what I'll do is I'll add a 2k both sides, and negative 3 is equal to k. And then, however, we got to make sure if we plug that in, that's going to work. And that becomes a positive 3, and that one works. So it does check out. So you can plug it in and make sure it works. All right, next one. Again, we have a summation. So basically what you want to do in this case is just go ahead and use the formula. And I did work on it because I was like, I don't remember this formula. So this is going to be n divided by 2 times an a sub 1 plus a sub n. Okay, now what is a sub n? A sub n is going to be this term. So a sub 7. So let's go and plug that in. So 6 times 7 is going to be 42. So that's equal to a 45. Let's go and plug in a sub 1. So let's plug 1 in for n. So 6 times 1 is going to be 6 plus 3 is going to be 9. Okay, so I have the s of 7, which is basically the sum here, is going to be a 7 divided by 2 times a 9 plus a 45. All right, so now let's just go and plug this into our calculator. So 9 plus 45. 9 plus 45, shoot. 9 plus a 45 is a 54 times 7, and then divided by 2. And I get a 189. Ooh, voila. No, we're not focusing on geometry. It's just the way a lot of the questions came in. Oh, and I got another one too. Forgot about this one. We just have a lot of logarithms today. Round your answer to the nearest hundredth. Okay, so again, in this case, when we have multiple logarithms, so we can't use the cancel out the logs here, because what we do is we don't have a logarithm set equal to another logarithm. So that's the first thing we're going to want to do here. We're going to have log as x over 6 is equal to a log of 4 squared. Okay, so just using the rules of logarithms to condense this down to one logarithm, and then to put the 2 up top. Now I have logarithms with the same base, which is 10. So therefore, I can now set the arguments equal to each other. So x over 6 is equal to a 16. And then multiply by 6 on both sides, right? And x is going to equal to a 96. And again, you can just plug that in, make sure that is going to work. But again, as far as positive, it's not going to be extraneous from there and there. Now, next one, we're going to do the exact same thing here. I'm going to rewrite this as a log of, let's see, x squared divided by a x minus 1 equals 1. Okay, so now this one's kind of a little bit different because now we need to get rid of our logarithm. So what I'm going to do now is going to be to get rid of the log. I can't cancel logs on both sides because I don't have a log on both sides, right? So what I can do in this case is exponentiate both sides to a base 10. What that's going to do is get rid of my logarithm now. So now I'm left with an x squared over x minus 1 is equal to a 10. Now I'll multiply by an x minus 1 on both sides. It's going to give me an x squared is equal to a 10x minus 10. Then I'll set that equal to 0. So x squared minus a 10x plus 10 equals 0. Now that is not going to be factorable, so I'll leave that to you to go ahead and solve it from there. Avery, if you do have any questions, feel free to go ahead and go to the, please go to brianmclogan.com/Q&A, because I got 4 more questions that came in, and unfortunately, guys, tonight is not a best night for me to be able to catch up on a lot of questions. So I'll try to see if there's anything I can answer tonight. I got 5 more minutes that I can possibly work on here. All right, so let's see if I can get anything else. It is all levels of math. I am just all over the board. However, whatever people submit to me is what I try to answer. Okay, I already got that one done. So if I would say I'm a second-year teacher. Awesome. I use it as a refresher every time I need a refresher. Thank you. Well, you're awesome. Well, thank you so much. That is awesome. And congratulations on becoming a teacher. I hope you're having a great school year. It does get better each and every year. Lex, I'm struggling with learning geometry. Do you have any tips? I've studied hours and I haven't gotten very far. Yeah, I think for studying geometry is a little bit different animal. I would definitely create a cheat sheet and have like all the formulas and everything, like theorems, formulas and everything, and kind of something that you can just kind of reference, from time to time or every night and day, because it's a lot of times in geometry, you feel like you just forget things, right? So it's very easy for on that. Awesome, Brian. So happy to help you out. Just AM here. Good. Okay. Let's see how. All right. I think I can do these again. All right. Well, all right, we got these. So let's go knock these out. So state any restrictions on the variable. So again, whenever we're looking at just straight up multiplication here, in this example, I just know x cannot equal a -1. Why cannot x equal -1? Because when you plug in -1 into the denominator, it makes the equation equal to 0, right? Which is undefined. But there's no restrictions here on this equation because 3 is in the denominator and it's never going to change from 3. Now, since this is straight up multiplication, I can divide out those terms because everything is separated by multiplication. So therefore, I can put parentheses in here though, because I have to multiply the 2 times both of those. And then I can multiply the 3 times 6. So therefore, I'll have a 2x minus 2 divided by 3 times 6 is going to be an 18. Now, actually, I actually don't need to multiply those out. Let's just keep that the way it is. I'll still put them in parentheses anyways. But so what I'll have is a 2 times a x minus 1 divided by a 18. Well, I can just reduce that to a x minus 1 all over a 9, where x cannot equal a -1. So that was A. Let's go and take a look at B. So B is the same kind of thing, but now we have to look at, we know A cannot equal -2. And then what happens is when you rewrite this as multiplication, which is kind of a hard one for students to recognize, and actually what I'm going to do is I'm going to factor out the 3 here. So when I factor out the 3, I'm left with a minus 2 all over an a plus 2. And then rewrite this as a product of a plus 2 divided by an a minus 2. Okay, so now I know a cannot equal -2, but then also a cannot equal a positive 2. So when you're doing the restrictions for division, you got to do the denominator of both terms, but then also the numerator of your divisor. Kind of gets a little confusing that way. Now let's just go and divide out our common terms. So a minus 2 divides out, a plus 2 is divided out. So my final answer is just going to be 3. All right. So let's see. Okay, I have a math test tomorrow. Algebra 2. I really don't know how to do the LCM. I was about starting. I watched some of your videos. I really know how to process. Can you help me? Yeah. I mean, I don't know what you mean, Gabe. Like if I have, 1 over 2 plus 1 over 3. You got to have common denominators to do that. So the easiest thing to do is just to multiply by your other term, right? So 2 over 2 times 2 over 2. right? So therefore you have a 3 over 6 plus a 2 over 6. Now they have common denominators, right? So therefore you can add those. So that's going to be a 5 over 6. Now again, this works. What if I had a x plus 2 over a 1 over x plus 3? It's the same idea. These are not the same. So to get a common denominator, I just multiply by an x plus 3 times an x plus 3. Here I just multiply by an x plus 2 all over an x plus 2, right? So then my final answer here is going to be a 2x plus 5, because I'm going to combine them, all over a x plus 3 times an x plus 2. Okay, now just to do one more little add-on here, if I had a 1 over 2 plus a 1 over 6, well, here you don't need to multiply them to 12. All you need to do here is just multiply by a 3 over 3, right? Because what that's going to do is give you a 3 over 6 plus a 1 over 6, right? You didn't need to multiply them. You just need to, they already had a common term, which was 2. So you just need to multiply this by 3 over 3. So therefore that's going to equal a 4 over 6, which you could simplify. So my point, what I'm saying is, well, what if I had this as like a x plus 2, and this was a 1 over a x squared plus 5x plus 6? You might say, well, how do I know that these have anything in common? Do I need to multiply these? Well, no, you need to factor them. So this is a x plus 2 times an x plus 3. Oh, they already have the 2 in common. So all I need to do is just multiply this by the x plus 3. Right? I don't need to do anything over here. So therefore my final answer is an x plus 3 all over a x plus 2 times an x plus 3. And there you go. Hopefully that was helpful for you.